Okay, in this video I want to go over some more complicated looking functions when it comes to finding the domain. So we're going to find the domain of this one first. And I've underlined here this square root. So what we have is the square root of x minus 2, that all minus 2, all under another square root. So what we're going to have to first examine here, and let's use our brains here because these require some thinking. They really do. And let's think it through together. So x minus 2 here, we know because that's its own square root. Let's just pay attention to this for the moment. Let's just look at this part and break it down one thing at a time and see if we can figure this out and come up with some valid reasoning. If we understand this is just a simple square root here. Just ignore the problem for the moment. Look at this one. What we have is we have a square root. We know that cannot be negative. So we remember that we would write it like this. And if I add the 2 over, what we're saying here is that x needs to be greater than or equal to 2. Okay? So let's just note that for the moment. We know that x needs to be greater than or equal to 2, at least. Now, since we know this, let's also take a look at now this part, which is the entire thing under this other square root. Let's say we have this now. This part here needs to also all be greater than 0, or greater than or equal to 0. Now why is that? The reason for this is we have this outer square root here. So if this all is negative now, we have a problem with this outside square root. Let's move this 2 over. So we move the 2, and let's square both sides here. This would get us x minus 2 needs to be greater than or equal to 4. And if we add 2 to both sides, we would get x needs to be greater than or equal to 6. So we have these two things here. Now why does it matter what we have here? Well, we have to satisfy both of these conditions here. So both, x needs to be both greater than or equal to 2, and it also needs to be greater than or equal to 6. In order for this to be in the domain. In order for something to be in the domain, it needs to be both greater than or equal to 2 and greater than or equal to 6. Now the only values that are going to be greater than or equal to both of these are the ones that are greater than or equal to 6. Okay, like let's take for instance 2. 2 works here, but that's not greater than 6. 3 works here, but that's not greater than or equal to 6. 4 works here, but not here. 5 works here, but not here. And now finally 6. 6 works here, 6 works here. 7 works here, 7 works here, and so on. We can see that everything needs to be greater than 6 for this to work. So the domain here in interval notation would just be this one. So it's x greater than or equal to 6, which we would write as 6 to infinity. So just make sure that when you have functions like this that are within other functions, okay, this is like a function within a function. This is like a composite function, okay? Just make sure that you're checking the domain of both cases here, and your domain itself, it has to be the ones that include everything from both of these together, meaning the intersection. Okay, that's written as A intersect B. All right. So if this is the domain of A here, and this is the domain of B, what we've done is we've found where they have everything in common between the two, and that was our domain. What was common? Intersection means common. Okay. So that would be the domain of this one. Let's look at another example of something that's a little more complicated in terms of finding the domain. let's take this apart a little bit here. So let's look at x, the square root of x minus 3 first. Okay, now when we do that, we know this already. We know that x minus 3 needs to be greater than or equal to 0. So what we have here, and let's list those kind of over here. This one tells us x needs to be greater than or equal to, not 0, 3. Okay? Because when I move this 3 over, I'll get this. X needs to be greater than or equal to 3. So I'm going to put a little box here of kind of what we know and organize our domains a little bit of what we found for each piece. All right, let's look at this one next. 1 over x. This one's an easy one. Denominator can't be 0. This means x can't equal 0. Okay, pretty easy one to deal with there. So let's put that down in our list. X can't equal 0. All right, let's look over here. Also, we have a problem. We have this. We have that x needs to be, this is a fraction here, so let's write that. Okay, so for this one, it shows number 1, x can't equal 6. And we know that because the denominator can't be 0, and 6 would make this 0. So let's write that in our little box. All right, we have that. And I'm going to make a little room here because I have one more. So we'll put it at the top here. We have this business on the numerator. It's a square root. It's a square root. So we know that x plus 1, in this case, that needs to be greater than or equal to 0 because of the square root situation. So that means that x needs to be greater than or equal to negative 1. So x needs to be greater than or equal to negative 1. So these are the four pieces of information that we've gathered from all of this. We've just taken it apart and gathered as much information as we can about each individual piece. Now let's see what we can put together from all of this. All right, so x needs to be greater than or equal to 1, negative 1. Let's look at the inequalities first. X needs to be greater than or equal to negative 1, but x also needs to be greater than or equal to 3. So the only way that these two are satisfied is if we just go with this one right now. X needs to be greater than or equal to 3. Notice I crossed this one out because if I picked, for example, I crossed this one out here, negative 1. If I picked, for example, 0, which is greater than negative 1, well, that's not greater than or equal to 3. So I can't pick that one. So I just crossed that out because it doesn't help us. There's no information there that's giving us anything new that will work for all of them. 3, however, will work for all of them. So I picked 3 instead of negative 1 because they were both greater than. Okay, now we also have a couple other things. X can't equal 0. But let's look here. X can't equal 0. We already know that x has to be greater than or equal to negative 3. So the fact that x can't equal 0 doesn't help me at all. We already knew that x couldn't equal 0 because it has to equal greater than, or it has to be greater than or equal to at positive 3. And 0 is not greater than 3. So we don't care about that one. But we do care about this one. X can't equal 6. 6 is in fact greater than 3. So we have to include that in our interval notation answer. So we start at 3. We realize that x has to be greater than 3. Now we can't just put infinity here and be done with it because we have to remember that we have this to deal with, this 6, okay? It goes from 3 to 6, union, and 6 to infinity. This would be the domain of this function up here. The idea was breaking it down into individual little pieces and finding the domain information of everything that we could find. We did that here. Okay, that's what we did. We broke them down and found each piece. Then we use our reasoning skills to remove some of this.